That's okay. Good for you. Don't try too hard though. Don't try too hard. You can really hurt yourself that way. That's all right, brother. You got more than I do. That was a great section of the movie Life of Pi, if you saw it, where the guy has to justify his name because his name is Piscine, and you can imagine that at all boys school in India how that name went over. Digits of pi. So they called him Pi, but here we go. But all the kids knew what his real name was. So he tried to make himself look mathematically superior by memorizing, I think he memorized like 100 or 500 digits of pi or something ridiculous. So there's your 3.14159. I think your TI goes out to about there. And then here's a lot more. But what's cool about this is as you go down through the digits of pi, you'll find places where there are 3 numbers in a row and 4 numbers. Yeah, you've seen them, Andrew. There are places where you get repetition, like 2 4s, 2 4s, 2 4s in line, and 2 4s. In poker, you'd call that a 4 of a kind, wouldn't you? 2 4s in line, 2 4s. You can get sequential ones. There's 3 2s right there.
Like 4 7s.
4 7s. Where's 4 7s? I see 3 2s again.
Up.
Boom. 4 7s.
Just beat that hand with 4 4s.
Well, yes, we did. We did, didn't we? There's got to be a 3 6s in here somewhere. It's got to be, right? Somewhere in there.
Yeah, down.
Did you see it? You guys see it?
4th row up from the bottom.
See a bunch of times.
Right, down.
Go to the right.
Down.
Go down 1 line.
So 5 9s?
Yeah.
Where the hell is that? Ah!
Oh, yeah.
That's 6. That is 5. That's 6 9s.
Well,
Holy hell! Now imagine if you were generating these random numbers in pi, and you happen to start generating in here, which you could usually do if you're generating these things randomly, and you get 6 9s in a row. You're going to question the randomness of the sample. Because why would 5 6 9 show up randomly in the course of generating random? They have to when you view it on the lens of we've just done 10,000 digits. It has to happen at some point. But the fact that it happened right there in the place we're looking is extraordinarily rare. So the only way to kind of mitigate that kind of pattern appearance is by doing more trials and see if the pattern still holds. Does that make sense? That's what we're doing here. Yeah, Benji, go ahead.
What I've never understood about pi, is it just like this secret room in like Cambridge University?
Oh God, no.
Scientists are like literally looking at a circular model and calculating, or are they generating random numbers?
It's that, there are functions that stand for it. So basically what you can do is you can express it as a series. Here, I'll show you one.
How they get new?
Well, you just need a better computer.
Yeah.
Expression for pi. If I can find one real quick for you guys. Here we go. So basically, there's one way to express pi. Here's another way. Here's a third way. Here's a fourth way. Here's a fifth way. And you see those dots on the end? Those are ellipses. If you let those things go out further and further and further and further, you get more and more and more and more digits. So all you need is more computing power. How often have you heard, we could find the next permutation that we need if we just had more computing power? Years ago, a Mersenne prime problem was solved by some dude hooking like 100 computers together to get the power he needed to get to the next step. That's all it takes. So at this point in history, generating more digits of pi isn't as impressive as it was, say, 100 years ago, when you actually had to do stuff manually. Like you had to actually go in here and crunch these things by hand, which is a pain in the butt, I mean, obviously, right? Nowadays, it's just who's got the best computer, who's got the most funding. So it's not quite as impressive as it is anymore. And as you can see, I just Googled digits of pi and got 10,000. That would have taken 200 years, 100 years ago, which means we'd still be doing it.
It was 100,000.
It was 100,000 digits of pi. Holy crap! So taking everything I just said, realize we'd be dead after trying. So the idea is, all it takes is computing power, and it's kind of, where's the clicker? All it takes is computing power. Where did I put it down? Right here. Here it is. So, anyway, sorry about the sidetrack, but it seemed like an apropos place to throw that in there. Let's generate some more digits, or some more data. Then I'm going to run and find a bulb for this projector. Hopefully.